introduce Kyle Young from South Carolina Electric and Gas. He is the supervisor of nuclear construction at the new units that are being built at the VC Summer Nuclear Station. Kyle was a civil and environmental engineering graduate from Tennessee Tech, and he is responsible for the oversight of construction activities for both units and the support facilities that are being built alongside the two units. He also serves as a chair for, and I have to read this because I know very little about this industry, so I'm sorry, Kyle. He serves as a chair for the APOG Construction Committee, which is an owners group for utilities, licensing, and constructing Westinghouse AP1000 nuclear plants. So, that sounds really big to me. But anyway, so I believe that he has some great information for us. I think everyone in the Columbia area is interested in what's going on at the nuclear construction site. Prior to the nuclear industry, Kyle was in project management and engineering in commercial development, and he worked for the U.S. Army Corps of Engineers, and I just learned he did a lot of work in and around the Nashville area, which of course is where my daughter is, so I'm happy that maybe she'll be safer as a result of some of that. So anyway, thank you so much, Kyle, for being with us. We look forward to what you have to say.
Thank you, Holly, and thanks for the invitation to be here. Today I'll talk a little bit about the VC Summer Units 2 and 3 project. Of course, Unit 1 has been serving the Columbia area for quite a many years. It went into operation in 1984 in a commercial operation, and actually fuel was loaded into the plant in 1982. I'm going to be focusing on the construction that we've been doing for the last 5 to 6 years at the site. And I started with the project in 2008, and we had just actually cleared some trees and started moving some dirt at that. Just to kind of get you oriented to who is the team constructing this project. SCENG is the majority owner of the project and will be the operator of the facility, just like at Unit 1. And just like at Unit 1, Units 2 and 3 will have a partnership with Santee Cooper, the state-owned utility here in South Carolina. Santee Cooper currently owns 45% of this project. There was some news in the past few months about a change in that ownership agreement. SCENG has agreed to take on 5% more of the project, relieving Santee of 5%, so it'll be a 60-40 split a couple of years after both units go into operation. Westinghouse is the designer of this plant. This plant is an AP1000 type plant. AP stands for Advanced Passive. So this is essentially a new generation of nuclear plants that are being built for commercial operation in the United States. The passive part is very important. All the plants that are currently operating in the United States, and there's about 104 of those in current operation right now, are what we call not a passive design, but an active design. So it takes either electricity, operator action, someone pushing buttons and moving levers and changing valves, to actually safely shut down the plant. In a passive design plant, essentially thermodynamics and gravity and backup battery power, DC power instead of AC power from the grid, are needed to safely shut down the plant. So that's the plant that was chosen to be built here at VC Summer. At our site, there's also 2 being built by Southern Company for Georgia Power customers in the Vogel site, which is just outside of Augusta, Georgia. Our general contractor is Chicago Bridge and Iron. When we started the project, it was actually Shaw Group, which is very heavy into the oil and gas industry and the heavy construction industry, along with the engineering design of nuclear plants. And during the course of the project, CB&I, Chicago Bridge and Iron, bought out Shaw Company. We started developing our application to be submitted to both the state level governmental entities plus the federal government, our prime regulators, the Nuclear Regulatory Commission, the NRC. So we started that application back in 2005, submitted that in 2008, also signed the contract and received some preliminary approval from the Public Service Commission here in South Carolina in late 2008 to do some limited site work. In 2009, we received full permission from the Public Service Commission to move forward with this project. We were in the process of receiving our combined operating license And that's a new regulatory technique that the NRC has used, and we're the first project to enter into that. So we actually have the permit to not only construct, but also to operate the plant already. We began site preparation, full bore site preparation in 2009, and received our license that allowed us to go vertical with construction in 2012. And right now we're in the middle of plant construction and moving toward the startup phase. We have approximately 3,000 construction workers on site. We expect about 3,500 temporary jobs to be available as we rotate folks in and out of the construction project. With units 2 and 3, we expect to double the permanent staff of SCENG at the plant. So there's about 600 to 800 folks that work at Unit 1, and we expect to have about that same number to operate both plants with this passive design, and the two plants are the same exact design. So we expect to double our staff. The actual plants cover about 25 acres, but we have about 1,000 acres under development for laydowns, support areas, and I'll walk you through a couple of photos of what the site looked like. To get that workforce, it's definitely a skilled workforce that's needed in the nuclear industry. We've partnered with a lot of institutions here in the region, and especially in the Midlands and South Carolina area. You can see here some of the folks that we partnershiped all the way from technical schools to two-year colleges. Midlands Tech has been a key partner. We've also established partnerships with Aiken Tech for some of our operators to be trained there. And then we've got partnerships with South Carolina State, South Carolina, and Clemson as well. This is what the site looked like when I started working here in 2008. We had cleared a few of the trees on the site, and you can see that the units 2 and 3 are located right in the middle of the photo. Unit 1 is up at the top of the photo, and then we had an old training center that became our office where we worked out of for the construction project down at the south end, and that's about a 3-mile span between that office and Unit 1. 2 years later, we had done a lot of the site work and development. You can see some of the buildings to support the project, not the actual plant itself, starting to go vertical. We also had begun construction on our on-site concrete batch plants, so we make our own concrete on site. 2 years later, we had excavated the holes for the project, and that's where we were when we received our combined operating license, and we're allowed to go vertical with the actual plant construction. We've got a large building here in between. That building's 130 feet tall, and we'll get into that a little bit more about how we utilize that building to assemble the AP1000 plant. Currently, this is generally what the site looks like. We've got a number of fabrication areas on the site. These circles here at the bottom of the photo are rings for our containment vessel, and we'll walk you through how that construction is done and how those are installed in the plant. And with Unit 2, the first unit that's going to go into commercial operation, we had already come out of the ground, and we've got a number of the parts and pieces installed in the plant already. So Unit 2 was the first project that was started since 3 Mile Island in the United States. There were a number of projects licensed under construction at that time, but there are new projects that have been started in that time in almost 30 years. So it was a very significant event to place our concrete base mat, the foundation of the plant. We placed over 7,000 yards. It took us over 2 days to make this placement. We started at night. It was a pretty cold evening, so you're actually going to see some plastic get rolled out on top of the reinforcing mat that we had laid out. So as we heated up the rebar to keep that temperature even as we placed the concrete. You can see a number of pump trucks. That's the equipment with the orange moon that's going to move and place concrete. We had up to 100 plus personnel on the base mat during the placement, and it took about 52 hours to make this placement. And again, this was the first safety-related concrete for a nuclear plant put in the United States in about 30 years. One of the key aspects of the project is that we are building this modularly. And what that means is we build it very similar to the way the shipbuilding industry has been working as aircraft carriers and submarines and those large naval vessels have been built in parts and pieces that are assembled in factories, moved to the actual site, and put into place with large cranes, usually a gantry crane at a port. On our site, we've installed what we call a heavy lift derrick. This is the world's largest mobile crane. The boom of the crane is 560 feet in the air. I have seen the boom of the crane crane from a couple of the buildings in downtown Columbia. The project site is located a little over 20 miles north of Columbia, so you can actually see the boom up in the air when it's boomed up. This is a photo of the first piece of equipment that was installed in the plant. Excuse me. This was a steel cradle that's going to hold the containment vessel, and we'll show you a little bit of a picture in a minute of that being put in place. So we fabricated the containment vessel bottom head. These plates were forged excuse me, in Japan and shipped to the United States. Came through the ports of Savannah and Charleston up to the site. We did all the welding, hand welding on the site to put all those pieces and parts together on a pad. Moved it over with transporters, hooked it up to the heavy lift derrick, and then placed it in the plant on that steel cradle that we had put on top of that base mat. The base mat is 6 feet thick, and the bowl itself is about 130 feet wide. Thank you, sir. Inside that vessel, we've already started to put parts and pieces of the plant in place. Again, this is an aspect of modular construction. These steel containers are really just concrete forms that we're going to leave in place. So instead of putting up plywood or removable forms that you'd see in typical construction, we're actually going to pour concrete up and around these steel forms that we've made at off-site facilities, leave them in place, and then those just become the walls of the rooms in the plant. The taller structure in this photo, kind of up at the top, is where the reactor vessel will go, inside the containment structure. This is a picture inside that 130-foot tall building, that 13-story tall building. We call it the Modular Assembly Building because that's what we're doing. And this is a picture of our CA-20 module. Essentially, these are rooms that are going to be in the plant. The upper portion of this is where we'll store all the spent fuel for the plant on site until it cools down. So it'll be in a cool pool of water in a safe condition in the plant. So this component was comprised of 72 different submodules. So it's essentially a wall. Essentially what will fit on the size of a flatbed trailer and be towed to the site. We bring it to the site with a special piece of equipment that upends it 90 degrees. We lift it up with one of the 3 cranes that's inside this building, set it down on a platen, which is just a steel pallet, so we can align those pieces and parts together, put them together, and then we move it outside of that building. We actually take the wall of the building down when we do this operation. So we've got 4 large moves like this that will come out of the building. We'll take the wall down. Two components like this, one for each plant, and another 2 super modules that go inside the containment. So we hooked this up to the heavy lift derrick, moved it, rotated around so we could just slew the crane around and put it in place. And this was about a 40-minute operation once we got it off the ground to get it in place. That component weighed about 1,100 tons.
It's 2,000.
This is the picture of the containment vessel lower ring. So we've got 4 courses of plates. These particular plates, again, were made in Japan. They're 1.5 inches to 1 3/4 inch thick steel. So it's a very thick barrier to safely and securely operate the plant. And there are 3 of these types of rings that sit on top of that bottom head, that bowl structure that we've already put in the plant. And there's a top head that goes on it. That all forms a pressure vessel. So just like a tank that you see in any kind of manufacturing plant, except a little bit bigger in this case. So we've already placed the first of 3 rings on top of the containment vessel. The containment vessel bottom head and this ring are in the range of 900 tons. So we utilize that heavy lift derrick, and that derrick is positioned so that it can make those placements in either plant, in Unit 2 or Unit 3. It runs on a rail type system. The rail gauge is about 2.5 times the standard railroad gauge, so it's a pretty heavy duty piece of equipment. We also use it to assemble our turbine building. This is similar to any kind of power plant, the secondary side of the plant, as we term it. So we make heat in the primary side of the plant inside that containment vessel using the fission product that goes on inside the reactor. And on the secondary side of the plant, we have a number of big structures that go in the plant to support the turbines. The turbines are pretty heavy pieces of equipment. And we also pre-assemble a lot of those sections. So we assembled essentially 3 column lines of the building of structural steel outside, hooked it up to the heavy lift derrick, and placed it inside the building. This is a photo of our condenser that sits underneath that turbine to condense water. One of the 3 condenser sections that we have being put into place. There were 9 lifts that it took to place all 3 condenser components inside the first unit. This is another new technology that we're using at this plant for the first time in the United States. There's a plant in Canada, many plants in Japan and in Europe that utilize this, but it's a spring dampening system. There's a lot of vibration that occurs, as you can imagine, with a generator or any kind of piece of heavy rotating equipment in a plant. And these spring-type systems were engineered by some folks in Germany and Switzerland, and they've been installed in plants successfully. And allows construction to proceed much faster, because typically on a turbine building project, you want to place the foundation for those turbines and let that concrete sit and harden for a year until it cures and there's no movement. But with the spring foundation, this actually improves our construction process. So this is a picture of the turbine building as it sits today. So we have all the condensers installed, and we're starting to put structural steel in the other portions of the building. We also have 2 cooling towers per plant. So we don't use, at VC Summer, we don't use the big hyperbolic towers that you see in a lot of the documentaries about nuclear plants with the steam, essentially condensed water coming off the top of that. We use a lower profile condenser cooling system in a form of a cooling tower. So it's got 16 fans that sit on top of it. We've already finished 2 out of the 4 of these on site, and I've got 2 more under construction. This is a global project, and Holly, it's one of the reasons we've had to reschedule a couple of times to come and speak to y'all, because we have parts and pieces that are being manufactured all over the world. And we, SCENG, as the owner of the project, and as the licensee to the NRC and eventual operator, take great care in monitoring how these parts and pieces are getting manufactured. So we've got representatives that visit us, either through our contractor or through SCENG, to all these facilities. Some of the larger components, larger forgings that are required for a nuclear plant can only be made in Southeast Asia. So you'll see that some of our turbine components, containment vessel, condensers, and reactor vessel are all made in Korea or Japan. There are a lot of components that are made in the United States that have already arrived on site. This is a picture of our reactor vessel as it came on the rail to the site. It was delivered through the Port of Charleston. There's a specialty rail car that rides on so it can make those turns with a number of axles on the car. Another picture of our turbine being offloaded from the ship at the Port of Charleston. In the bottom of the photo, this is the largest piece of equipment that goes in the AP1000 plant. That's a de-aerator. And it was brought to the site via ship through the Port of Charleston. We barged it as far as we could up through the Santee River system to their locks and their lakes. And then we took it through the back roads of South Carolina until we got to I-77, and we had to make that crossing. So we had a lot of cooperation both from a number of utilities, SCENG and other cooperative utilities in Santee Cooper, to move transmission and distribution lines as we went, and also, of course, our transporter and the local governments as we caused a little bit of a traffic jam. So through a lot of the local towns we took it through, it looked a little more like a parade with folks standing on the sidewalk taking photos of this going by.
How low is that?
That is about 180 feet in length. So this is a picture of our switch yard. It's the largest switch yard in the SCENG system for Unit 2 and 3. We went live with that switch yard in February of last year. We've made a number of tie-ins and connections to Unit 1's system already. We actually are in the process of removing a small switchyard as part of our hydro project and relocating some of the lines there. And Santee Cooper has started to tie in some of their lines. And you may see some of the lines have already been put in throughout the Columbia area, some of the future transmission lines that serve the project. We use existing transmission corridors for almost all the new lines that are being run out of these two plants, both us and Santee Cooper. So you may see some of the new metal type poles going in throughout the Columbia area. That's what that work activity is. This is a picture of a simulator. There are no current nuclear plants that have an all-digital system in the United States. And this is a picture of a simulator that you see any kind of operating plant. All the controls are through just a mouse, a click system. And you can see everything up on the screen. On the left side is the primary side of the plant where the heat is made in the reactor and inside the containment. On the right side is the secondary side of the plant. We have extra monitors for our folks that call up procedures and processes that they need to refer to as they're operating. And at any given time, there'll be a minimal of 4 staff here in this room, 2 operators at the front, a supervisor, and then a technical specialist or an engineer in the control room to support those folks if there's any issues or any questions. So we already started training on this. We've hired trainers right in the 2009-2010 time frame. We actually built a new building wing onto our existing training facility, put a simulator in that building for each unit, so we have 2 of these already in place. And we have operators that we've hired. So in addition to those 3,000 folks that are working on the construction site, we have almost 500 folks that are already working for SCE&G on the Unit 2 and 3 project, either going through training for operations or maintenance of the plant, or engineers that are working on overseeing the construction and will eventually be the engineers for the permanent plant. And with that, I'd be happy to take any questions. Sir?
You mentioned that there were some parts that, major parts that you had to acquire that can only be made in Korea and Japan. Why is that? There's not the know-how here in the United States or the experience?
It's not necessarily a case of the know-how or the experience. It's the case of the investment into the large forging equipment. Essentially, the 3 largest forgers in the world that can make these really thick, curved type pieces are in Korea, Japan, and also Switzerland as well. So most of the large forgings for any kind of product are made in Southeast Asia these days.
Thank you.
A lot of those are designed though in America, aren't they?
Yes, Westinghouse is
he's an engineer in Rotary, and he designed them and take it over to Japan, actually.
right.
And it would be made there.
Right. Westinghouse is an American-based company. They're currently owned by Toshiba, who's a Japanese company. They were owned when we started this project by British Energy, and they had split from the old Westinghouse, the TV maker and the light bulb maker, many years ago. And this is Westinghouse Nuclear that's designed plants in the United States really since the 50s and 60s when the first commercial operating plants were being designed. Yes, sir.
Since this is a newer model, is it safer than older models in terms of the construction and anti-terrorism? If somebody flew a plane into this, what would happen, and how is it safer than older models?
It's very much safer than older models. Essentially what Westinghouse did is take the best of the existing designs in the plants and simplify them as much as possible. So one key aspect to safety is the fact that it's a passive plant. So essentially an operator can walk away from this plant and no action is required for a period of 72 hours to have the plant remain in a safe condition. After 72 hours, essentially you just need to refill some tanks using a fire truck or a pump and a water source, which we've got Monticello Reservoir very close to the plant. And we just refill those tanks. And so that's one of the safety features. As far as terrorism, this plant went through a major redesign during that application period of 2008. And it's one of the reasons it took a little bit longer than anticipated to to receive the license. Some of the rules and regulations from 9/11 and some of the resistance needed for aircraft impact resulted in the cylindrical part, actually the round building here, being changed in design. So it was originally a concrete containment building, like you see at most nuclear power plants, and now it is a steel composite concrete. So there's a 3/4 inch steel plate, 3 feet of concrete, another 3/4 inch steel plate, and those two plates are bound together in tension through the use of numerous tie rods and pieces of steel. And it's a design that was very much enhanced from what Westinghouse already had permitted through the Nuclear Regulatory Commission before 9/11 years ago, when they had first submitted this design to the government to be permitted.
I'm curious about the estimated cost.
The estimated cost in 2007 dollars was about $10 billion. It was right at 9.8. SCE&G and its customers, of course, share 55% of that cost. And there is a mechanism that's been in place here in the state of South Carolina and Georgia called the Base Load Review Act. And there's a great benefit from that. While we built this plant in the past, the company would not have been able to charge for the interest incurred to borrow the money to build this type of facility, not be allowed to charge our customers. Right now, we are charging for that interest, and the net result of that is that this went from an $11 billion project to a $10 billion project over the life of the plants, which is 60 years. So it's a significant savings to all of us who are customers. Yes, ma'am.
To me, this looks like everybody should be investing in Legos, because it's just like what you saw your children do with Legos. But I know how much you've worked with the education system throughout the state. Tell me what those jobs are that you were specifically thinking that we should be training for, should be offered, or what the need is.
Well, right now on the construction job, we have an extreme need for basic skills like carpenters. There are some folks that we've hired that were working in the residential or commercial development industry, but we're actually, just because of our need more carpenters. Welders are a critical need in the construction phase, and will be even into the operation of the plant as we do maintenance and repair. And we work with a number of schools, some technical schools in Rock Hill and the Fairfield County area, including Midlands Tech, that's placed a new campus and a job center in Winsboro. So that's some of the trade skills that we need. We've always need engineering skills. Most of the engineers that work at a plant like this are mechanical engineers, not necessarily nuclear engineers. Nuclear engineers, there are not a lot of those in the pipeline right now. Years ago, South Carolina State started a nuclear engineering program, and right now they graduate over half of the minority nuclear engineers in the country. Some of the other skills long-term for the plant are technicians for health physics or radiation protection. Aiken Technical College started a program, and we've actually supplied training material and actually embedded one of our instructors there for many months to help them develop that training material so that folks coming out of there can work in the nuclear industry. And there's a lot of nuclear industry in the southeast region, especially in the Georgia and Carolinas. We've got a lot of these companies that build and design plants located in the Charlotte area, in the Columbia area. Westinghouse makes nuclear fuel here in Columbia. We've got this plant, the Vogel plant, a number of other operating plants, and of course the Savannah River site. So Aiken Tech was happy to work with us and develop those skills. And otherwise, there are just a number of jobs, generally the technical area, so math and science skills are definitely needed.
When will it be online?
These plants are scheduled to come online right now. The first unit toward the end of 2017, early part of 2018. The second unit is scheduled about a year after that. Yes, sir.
What sort of capacity ultimately will the 3 units have?
Well, the 1,000 and the AP1000 nominally stands for 1,000 megawatts.
Okay.
We'll actually have closer to 1,100 out of these 2 plants. It depends on your site-specific design, what your cooling system looks like, and that sort of thing. And just for some perspective, Unit 1 is right at 1,000 megawatts.
Are there any coal-fired plants that are scheduled to be shut down as a result of these coming online?
There are a number of coal-fired plants that will be shut down, and SCNG has made that announcement. We've already made that move to shut down a few of our older plants. We've put some scrubbers on our plants, but we anticipate that we're going to have a very diverse generation system. Essentially, we'll have a third coal and gas and nuclear. And so the other 5 to 10% could come from other sources such as hydro or solar. Sir.
In 2016, we're scheduled here in the Richland School District 2 to open what we call the R2I2, which is the Richland 2 Institute for Innovation. But we were going to focus on preparing students for offering courses for students in a flexible setting, supply chain logistics, advanced manufacturing, advanced technology, and IT. Is there a person in the organization that we could contact to possibly partner with or have a conversation with to have you guys come in and where our students are going to be given an opportunity to get a hands-on experience in these fields prior to going into a 2-year track or 4 years university or into the workforce, so that we can kind of start preparing them earlier for some of these demanding jobs that I think kind of lined up with what our vision will be over the next 2 years.
I can give you a contact within our company, and our public affairs group would probably be the first place to start, and then we can go from there as far as the technical aspect. I would also encourage you to look at some of these folks that we're partnering with, Westinghouse and CB&I specifically. They're located, Westinghouse has a fuels facility here in Columbia. CB&I is located, their power group out of Charlotte area, and they offer a number of internships. And SCE and SCANA